Hello students, welcome to Eshwari Thaniksha channel. In this video, I'll teach you a super trick to calculate the Van Hoff factor. So finding Van Hoff factor is very important in the calculation of colligative properties. So you would have studied colligative properties in this chapter. Colligative properties. So which are the four types of colligative properties you have studied? So the first one is relative lowering of vapor pressure. Second one is elevation in boiling point. So elevation of boiling point. Third is depression of freezing point. And what is the fourth one? Fourth one is osmotic pressure. So these are the four types of colligative properties. So colligative property meaning is the properties which depends upon the number of solute particles present. It doesn't depend on nature of the solute, but it depends on the number of solute particles present. That is called as colligative property. So if you want to calculate this colligative properties, you need to know the value of Van Hoff factor. Only then you can easily calculate this colligative properties. So in this video, I'll teach you a trick using that easily you can find the value of Van Hoff factor. So let us start the video. So students, before going into the video, if you are new to our channel, subscribe our channel and also share this video with your friends. So go through the other videos. You will find it very helpful for your NEET preparation and also if you are preparing for JEE. So first let us start Van Hoff factor. So it is represented by small I. So small I represents Van Hoff factor. So what is the trick we are going to use here is, so trick number one. So what is trick number one is, if you see if the solute is non-electrolyte, then you can write Van Hoff factor I value will be equal to 1. So this is trick number 1. Trick number 2 is, if the solute undergoes dissociation. So if it is undergoing dissociation, then the value of I will be greater than 1. And trick number 3 is, if the solute undergoes association, then the value of I will be less than 1. So this is the trick you are going to remember. So now I'll teach you with examples how to find. First learn this trick. So learn the values, then easily we can calculate. So now let us take one by one and find out how to find this value. What is first one? First one is non-electrolyte. So first we will take non-electrolyte. First one, non-electrolyte. So what did I say? Now what is the value of I here? I value should be equal to 1. So let us see how the I value will become equal to 1 for non-electrolyte. So examples for non-electrolyte, if you want to write, it will be glucose, urea, sucrose. So all these are non-electrolytes. That is, if you put this into water, they are not going to break into ions. They will not dissolve. That is the meaning of non-electrolyte. So now since they do not dissociate in water, so here we are going to use a formula. So the formula what we are going to use is I is equal to 1 plus n minus 1 into alpha. So this is the formula we are going to use to find the value of I. What is n here? N is the number of ions formed from molecule and alpha is degree of dissociation. Degree of dissociation. So now what is the value of alpha here for non-electrolyte? The value of alpha will be equal to 0 because they are non-electrolytes. They are not going to dissociate in water. So they are not breaking into ions. They will not dissolve. Therefore alpha value will be equal to 0. Now substitute in the equation, see what you will get. I is equal to 1 plus n minus 1 into alpha value is 0. So then this entire thing, that is n minus 1 into 0, this entire thing will become equal to 0. Then what will be the value of I? So you will be getting I value is equal to 1. Clear? So that is what we have written in the trick here. I value is equal to 1 for non-electrolyte. So see the trick what we have written. I value is equal to 1 for non-electrolyte. So remember the examples: urea, glucose, sucrose. These are some of the examples for non-electrolytes. So now we'll go for the second one. What is second one? Second one is dissociation of the solute. So second one is dissociation. For dissociation, what is the value of I? We have written I value should be greater than 1. So here let us take some examples. So first example is of the strong electrolyte. Let us take strong electrolyte. Strong electrolyte. Example for strong electrolyte, or we will take strong electrolyte. Example, we will take strong acid. So here let us take strong acid. So strong acid example, if you want to write, you have HCl, you have sulfuric acid, H2SO4, you have HNO3 nitric acid. So when you add this into water, what will happen? When HCl is dissolved in water, it is going to break into H plus and Cl minus ion. So there will be complete dissociation. Strong acid meaning is completely it will dissociate. 100% it will dissociate into its ions. Even sulfuric acid will dissociate completely. Nitric acid also will dissociate completely in the water. So there is dissociation of the acid is taking place here. So now how to find the value of I here? So now let us write the formula. Same formula we are going to use. I is equal to 1 plus n minus 1 into alpha. Same formula we are going to use. So here what is the value of alpha? Alpha is 100% here. 100% meaning is completely dissociating. So HCl will completely dissociate. So 100% it dissociates. So 100% means it is equal to 100 divided by 100. Percentage means 100. So equal to 1. Alpha will be equal to 1 here. So substitute that in the equation. See what you will get. You will be getting I is equal to 1 plus n minus 1 into 1. So this is equal to 1 plus n minus 1. So plus 1 minus 1 will get cancelled. You will be getting I is equal to n. So here we are getting I value is equal to n. So what is exact value of I then? So let us take the example of this acids and we will find the value of I. So remember, I value is equal to n for strong electrolyte. Here we have taken strong acid. So now we will take some examples of strong acid. So here first I'll take HCl. So HCl, when it is added into water, it is going to break to form H plus ion, and then it is going to form Cl minus ion. So how many ions are formed here? So you can see 1 and 2. So there are 2 ions formed. N is nothing but the number of ions which is formed. See here what we have written in the beginning. see here what we have written. N is the number of ions formed from the molecule. So here HCl, from one HCl you can see H plus and Cl minus ion is formed. So totally how many ions are there? There are 2 ions. Therefore you will write N value is equal to 2. Then what is I value? I value also will be equal to 2. Correct? Why? Because here we have written I is equal to N. Therefore, if you are getting N is equal to 2, then I value also will be equal to 2. So, Van Hoff factor for HCl is 2. Is that clear? We'll take one more example. So, second example. We'll take HNO3, nitric acid. So, how it is going to break now? It is going to break as H plus and NO3 minus ion. So totally how many ions are present? There are 2 ions. N is equal to 2. Therefore Van Hoff factor also will be equal to 2. Clear? So one more example. Third one, H2SO4. So now how this is going to break is, this is going to break as H plus, then H plus, and then SO4 2 minus ion. So here you can see there are 2 hydrogen. So it is going to break as H plus and H plus, and this is going to break as SO4 2 minus ion. So now totally how many ions are there? 1, 2 and 3. So totally there are 3 ions formed. So the value of N will be equal to 3. So if N value is equal to 3, what is Van Hoff factor? Van Hoff factor for sulfuric acid will be equal to 3. So one more example you want to try. So one more example, fourth one, HClO4. So for this one I want you to try and write the value of I in the comment section. So here this is going to break as H plus and ClO4 minus ion. So this is how it is going to break. So for you have to find what is the value of N. Already I have written the ions here. So you have to write the value of N and also the value of I. Find the value of N and I and write in the comment section. So what is Van Hoff factor for HClO4? So write your answer in the comment section. So for strong electrolyte, that is strong acid, we have seen. Now let us take some example for strong base. Strong base. So strong base example we will take. So the first example we are going to take sodium hydroxide, NaOH. So how it is going to break now? It is going to break as Na plus ion and OH minus ion. Correct? So what is the value of N here? The value of N will be equal to 2. What is Van Hoff factor? I also will be equal to 2, because you know that I is equal to N for strong electrolyte. Second example we will take BaOH twice, barium hydroxide. So barium hydroxide, how it is going to break now? So this is going to break as Ba 2 plus ion and then OH minus ion and then OH minus ion. So how many ions are formed totally? 1, 2 and 3. So therefore you can write the value of N is equal to 3. And what is Van Hoff factor? I value also is equal to 3. So is this clear? Strong acid, strong base, and even for the salt. So here next is salt. So even salt is going to break in water and it will form ions. So here one example we will take. First example is NaCl, sodium chloride. So sodium chloride, how it is going to break in water? It will break to form Na plus ion and Cl minus ion. Then what is the value of N? N value is equal to 2. then I value also will be equal to 2. Let us take one more example. So second example, I'll take K4 FeCN 6 times. So when you dissolve this in water, how it is going to break? So it is going to break as K plus ion. So K plus ion, how many K? K is potassium. How many K you have? You have 4K. Therefore, you will be getting 4K plus ions. 1, 2, 3, then 4 K plus ion you will get, and then you will be getting FeCN6 4 minus. So this is how it is going to break in water. Count how many ions are there. 1, 2, 3, 4 and 5. So totally there are 5 ions present. So therefore the value of En is equal to 5. Then what is Van Hoff factor here? Van Hoff factor will also be equal to 5. Is that clear? So for strong electrolyte, that is for strong acid, so make a note of this. So for strong acid, strong base and salt, I will be greater than 1, and you will be using this equation. I is equal to N. N is nothing but the number of ions formed from the molecule. So see how a molecule, how many ions it is going to give. So that is the value of N, and N value will be equal to I. I is nothing but Van Hoff factor. So for strong acid we have seen, for strong base we have seen, and then we have seen for the salt. So next we will take for weak acid. Suppose if a weak acid is given. So next we will see for weak acid. So weak acid or weak electrolyte. So let us take weak electrolyte. So under this weak electrolyte, particularly we will take weak acid. Weak acid. So weak acid, how it is going to dissociate in water? Whether it will completely dissociate in water, the answer is no. So it will only partially dissociate. Weak acids and weak bases will only partially dissociate in water, whereas strong acid and strong base will completely dissociate. Since it is only partially dissociating, so you have to calculate the value of I here in a different method. So for weak acid, we will see how we are going to calculate. So how the question will be given is, one example I'll take here. Suppose 0.1 molar HCN. HCN is a weak acid, is 10% ionized. Calculate Van Hoff factor I. So this is the question. So question given here is 0.1 molar weak acid is taken and it dissociates only 10%. So calculate the value of Van Hoff factor. So students, one trick what you have to remember here is, whenever percentage is given in the question, so it can be 10%, 20%, 30%, 50%, 60%. If percentage is given, then always remember it will be a weak acid or it is dissociating only partially. When it dissociates partially in water, only then this percentage will be given. So when this percentage is given, how we are going to calculate is, so we are going to calculate in this way. That is, so same formula we are going to use. That is, write the formula I is equal to 1 plus n minus 1 into alpha. So now write here the value of n. So the value of n will be equal to 2. Why it is equal to 2? Because HCl, it is going to break to form H plus ion and then it will break to form Cn minus ion. So totally how many ions are there? 1 and 2. So there are 2 ions formed. And what is alpha here? Alpha is equal to 10%. Degree of dissociation is 10%. So 10% means it is 10 by 100. So 10, 10 will get cancelled. 1 by 10 is nothing but 0.1. So substitute this in the equation. So I value will be equal to 1 plus, what is n? N is 2. 2 minus 1 into alpha is 0.1. So this is equal to 1 plus 1 into 0.1. So this is equal to 1 plus 0.1, which is nothing but 1.1. So the value of I you are getting here 1.1. So is that clear? So whenever there is dissociation, remember the I value will be always greater than 1. But if it is strong acid or weak acid, it depends upon. For strong acid, directly we can calculate. We can say N value is equal to 1. For strong, N value is equal to I. For strong acid and strong base. If it is weak acid, we have to calculate by this method. So here also we are getting a I value greater than 1. So is that clear? This is for dissociation. So second one we have studied about dissociation, where I value we are getting greater than 1. So next third trick we will study association, where I value should be less than 1. So next we will take association. Third trick we are going to learn association. So for the association, remember that I value will be always less than 1. We will see how it is. So association meaning here is, we will take one example here. So association meaning is 2A will give rise to A2. So meaning is two solutes are reacting together. As a result, here you can see dimer will be formed. Two monomers will combine together here. So these are two monomers. Monomers will combine together to form dimer. So one more example, if you take 3A will give rise to A3. So here this is nothing but trimer. So monomers, three monomers are combining together and a trimer will be formed. So here how to calculate is, here remember that this will give you the value of N. So this is the value of N. So N is equal to, here N value will be equal to 2, and here in this equation N value will be equal to 3. So from here we are going to write the value of N. So here the formula what we are going to use here is a different formula we are going to use. That is I is equal to 1 plus 1 by N minus 1 into beta. So what is beta? Beta is nothing but degree of association. Degree of association. So we'll take one example and we will understand this. So example, acetic acid. Acetic acid is dimerized in benzene up to 30%. Up to 30%. Find the value of I. I is Van Hoff factor. So this is the question. You have to find I value. So here let us write what is given in the question. N value. What is N value here? In the question it is given dimerized. Dimerized meaning is, so two monomers are combining to form dimer. Therefore N value will be equal to 2. If it is trimer, then N value will be equal to 3. And then it is given 30%. So dimerized up to 30%. Meaning is beta is equal to 30%. So this is equal to 30 divided by 100. 10 will get cancelled and this is equal to 0.3. So now substitute this in the formula. So I value is equal to 1 plus 1 by N. N value is 2 minus 1 into beta is 0.3. So how much you will get? 1 plus half minus 1 is minus 0.5. So minus 0.5 into 0.3. So this is equal to 1 minus. So 5 3s are 15. So you will get 0.15. So here finally you will be getting I value is equal to 1 minus 0.15. You will be getting 0.85. Correct? So this is the value of Van Hoff factor here. So here you can see the I value is less than 1. So this is the third trick. So wherever there is association, association means combination. So here acetic acid, two acetic acid will combine and they will form dimer. So that is called as association. So wherever there is association, you can see IE value is less than 1. So this is how we find IE value, that is Van Hoff factor. So write down this trick. For non-electrolyte, IE value will be equal to 1. For dissociation reaction, IE value is greater than 1. For association, it is less than 1. So this is how we find the Van Hoff factor. So students, did you like the trick? So if you like the trick, you can subscribe our channel and also share this video with your friends. Go through the other videos. It will be very helpful for you in your NEET preparation. And also if you want to join our online classes, I have given my WhatsApp number as well. So you can text to my WhatsApp number. So I'll meet you in the next video, students. All the very best.